In this lecture, we're going to discuss a type of problems called a chicken and rabbit problem. This is going to serve as a demo of what the video classes we intend it to be, and to see how effective this is going to be. The problem that I choose here is a classical problem. It's called a chicken and rabbit problem. You will see that it has many variations of the same problem, and we're going to discuss some in this lecture as well. The problem statement goes as the following. You have that problem in your sheet. So for these lectures, we're going to have a handout sent out before the video, and you're going to use the handout together with the videos. The problems will all be there. And then after the video, we're going to have a set of problems assigned by us on MathCup.com. And students going to work on the problems on MathCup, and the parents will get a weekly feedback on how the kids are doing. And the teachers also get that feedback, so we'll know that what are working and what are not. And we're going to adjust our teaching pace and teaching points as well. So let's look at a problem. The problem statement is the following. In a cage, there are chickens and rabbits. The total number of heads is 10, and the total number of legs is 26. And the question is, how many rabbits are there in the cage? So some students look at this problem and will think that, well, this is not too real a question, because if you know the total number of heads, and for sure the head of a chicken looks very different from a head of a rabbit. So, if you're counting the number of heads, you definitely know how many chickens there are. I agree with all that. And I also agree with the fact that a lot of math questions are artificial. The important thing here is the logic, because you will see there are other variations of the problem will be a real problem, and the approach you get here will be exactly the same as the approaches to attack those other questions. So the question is just like given. The total number of heads is 10 and total number of legs is 26. And we know that each chicken has 2 legs and each rabbit has 4 legs. So how we are going to figure it out? Now, in all those video lessons, I recommend students take a pause here and think about a problem. And you might be taking 2 minutes or 3 minutes or 5 minutes, depends on how you, how you're going to take an approach and try to solve the problem. I think it's a very important step before you go on the material, because as you try, you'll appreciate the ways we're going to talk, how we solve those problems. And you'll figure out, oh, actually, at this step, I kind of stumbled, but what the teacher is talking about actually makes a lot of sense. So I recommend you take a pause and think through. And if you're solving the problem by one method, you can go ahead and you will see that maybe some of the method we're going to talk about is going to be different and give you some, ideas of some extra understanding of the problem that helps you learn. And that's definitely our hope. So take some time. And here, I'm going to talk about actually 3 methods to solve this problem, or rather to solve those types of problem. The first method we're going to talk about is going to be trial and error. All right, let's add a layer. Okay, it's called trial and error. This method is not very beautiful, but it's effective. The second method we're going to talk about, it will be, I call it a unit modification method. Make a small change and you will find what the direction goes, and then you try to generalize. I would say this method is a generalization of the trial and error method. And the last method is the algebraic method. I would say for a lot of parents, when they learn a lot of math, they will prefer this method. On the other hand, actually I don't prefer this method because this kind of kills a bit of creativity, and we'll see why. So let's go through this method. First, trial and error. How we do? All right, we trial. So total number of heads is 10, and total number of legs is 26. Let's try, let's say 15 chickens. No, sorry, there are only 10 animals. So let's try 5 chickens and 5 rabbits. All right, then the total number of legs equals 5 chickens, so 5 times 2, those are legs from the chickens, and plus 5 times 4. And that's easy to figure out, and that's 30. Well, that's too many. Okay, so that indicates that the number of rabbits there are is too many. So let's try taking a little bit more chickens and less rabbits. Let's say 8 chickens. And of course 2 rabbits, because totally there are 10 animals. And then the number of legs equals 8 times 2 plus 2 times 4. Because 8 chickens with 2 legs and 2 rabbits with 4 legs, that equals 20. 8, 24. Legs. So that's too few. All right, so we are actually having too few rabbits. And kind of clearly that it will be between 2 rabbits and 5 rabbits. And the fact that when 2 rabbits, there are 24 legs, makes it really, really close. So let's just check 7 chickens and 3 rabbits. Well, the number of legs equals 7 times 2 plus 3 times 4, that equals 26. So hula la, we got the answer. Okay, and this is the method of trial and error. Now, by doing trial and error, you are kind of taking the indications, right? You're kind of using the number of legs and how far from the target to get an idea if you're close or not. And that's a very, very useful method. Okay, but you see that this method is a bit of tedious. And here we only have 10 animals. If you think about there are 100 animals, that you are kind of in a bit of trouble. So how we can improve this method? There is actually a generalization of this thing, and we'll see how we do it. So let's get another layer. So the second method, I call it, okay, it's my term. It's called unit modification method. We first start with an assumption. Let's assume every animal inside a cage is chicken. So assume 10 chickens. This means there are 0 rabbits, right? Let's look at how many legs. The number of legs equals 10 times 2 and plus 0 times 4, so we don't get it, equal 20. Okay, so 20 legs. And of course, the total number of legs in the cage, as we know from the problem, is 26. So we're missing 6. And why we're missing? Of course, because there are some rabbits. Okay, so we need to replace some chickens by rabbits. Instead of trying to guess how many replacements there will be, let's just do it one step by one step. Let's just take one, replace one chicken by one rabbit. What does that mean? We take out the chicken and put in a rabbit. Okay? So what's the change on number of legs? That's going to be, we take out one chicken, so we take out 2 legs. We put in one rabbit, so we put in 4 legs in. So that change is a +2. We're adding 2 legs. Right, of course, that complies with our understanding. Our guess is we need some more rabbits there. But replacing one chicken by one rabbit, we increase the number of legs by 2. But remember that replacing by 2 makes the total number of legs at 22. It's still not, has not reached 26. But once you understand replacing one chicken by one rabbit increased by 2, now you say that if I replace another chicken by another rabbit, replace another one. The change on number of legs is again a 2. That makes, of course, is 24 now. And here is 22. Okay, so this replacing one chicken by one rabbit, the total number of legs increase is always 2. So how many steps we need to do? Well, that's actually only need 3 steps, because from 20 to 26, we need to increase a 6. But replace 1, it's increased by 2. So how many replace? The number of replacement equals 6 divided by 2 equals 3. So we need to replace 3 times, and that means there will be 3 rabbits and 7 chickens. And this unit modification method hinges on this crucial idea, is by taking a small step, you see which direction the change is going to be. And you want to make sure that the change is going on the direction that you want it to be. And how many changes you're going to do depends on the final total number of changes divided by the small changes incurred by every little change. Okay, and we're going to look at this method more on the other problems. And here we can do the same thing by starting from the other direction. Instead of we assume every animal is a chicken, we can assume that every animal is a rabbit. Let's assume all 10 are rabbits. Then the total number of legs equals 10 times 4, right? That's 40. That's definitely bigger than 26. By how much? We need to reduce 14 legs. All right? Need to reduce 14. Now think about this unit operation. By replacing one rabbit by a chicken, reduce the number of legs change equals, you take out the 4 and you put a 2 because you're taking out the rabbit and you put it into a chicken. So you are reducing by a 2 or minus 2. Every time you are minus 2, minus 2, minus 2. And this is true for every replacement. So how many replacement you need to do? Number replacement equals, the final change I want to be is 40 minus 26. That's like starting with all rabbits, I want to go to 26. So I need to reduce 14. And every time when I do it, I'm reducing 2. So that's a 7, which means that you're going to replace 7 times, which means 7 chickens, because you're taking 7 rabbits out and put in 7 chickens, and then 3 rabbits. Okay, is it clear? So this is a method I call the unit operation, and does not require any algebra, and supposedly a 3rd grader should be able to do it. And we'll see this method is super powerful. Okay, now let's look at the last method for this kind of problem. And it is the algebra problem approach. And I'm going to just go very quickly on the algebraic approach, because, well, we're going to learn it, but I'm not exactly here. I'm just going to describe it. So let's assume the first way actually doing it is, you can using 2 variables. Let's assume x is number of chickens, y is number of rabbits. So x plus y equals 10, because the total number of chickens plus the total number of rabbits is 10, the number of heads. And if you count the number of legs, is 2 times x, because each chicken has 2, and 4 times y equals 26. So as you know, that using algebraic method to solving problems is basically changing the words in the question into math equations, especially changing all the constraints of different variables into equations. And here, the constraints 1 is the total number of heads. Constraint 2 is the total number of legs. And these are corresponding to equation 1 and equation 2. There are 2 constraints, 2 equations. And once you have 2 variables and 2 equations, you can solve it. And we're going to learn it, how to solve it in a later lectures. But basically, what you're here to do is you eliminate 1 variable by multiplying the first equation by 2. So 2x plus 2y equals 20. And the second equation you keep the same, 2x plus 4y equals 26. And then you take second equation minus the first equation. which means that you take the second one and minus the first equation, minus 20, this, and then becomes 2y equals 6, so y equals 3. Okay, dirty and powerful, and you don't really need to think too much using this approach. Some people call it good method. I don't agree for lower grade kids, okay, but that's your opinion. You can have your own opinion, not a problem. And a slightly different way I would say here is still using algebraic, but don't use two variables, is the following. And that might be good for certain students, especially we don't know how to solving many linear equations at the same time. So let's see how we do it. So we're only going to introduce one variable. X is number of chickens. Now, just from X number of chickens, from the total number of heads is 10, we can know the number of rabbits will equal 10 minus X. Agree? And then we're using the second constraint, the total number of legs is 26, to write down kind of the equation on the X. Just to count the total number of legs. So legs from chickens will be 2 times X, plus the legs from the rabbits will be 4 times 10 minus X. That will be equal 26. All right, of course, I assume that most of you know how to list those equations. And if you do not, you can look up classes that we'll have about using variables and write down expressions and write down equations. And then how you solve it, you're basically using distributive law for this with a parentheses. So 4 times 10, to expand those expression, you have to times 4 all inside. So that's equal to 2x plus 40 minus 4x. Okay, don't screw up on the minus sign. That equal to 26. But that will be 40 minus 2x equals 26. And then this is just basic how you solve equations. You plus 2x on both sides will be equals 40 plus 26 plus 2x. Right, on the left side, minus 2x plus 2x equals 0, so you cancel out. And now both sides, you minus 26 equals 14 equal 2x. So x equals 7. I'm changing to x equals 14. Okay, so this is the second method. Oh wait, the second method of using algebraic equations. But totally we talk about the 3 methods of trial and error. That's usually always a good way of understanding problem. The second method I call the unit operation method, which I think is the most powerful method for lower grades kids, and will give you the most insights. The third method is algebraic method, which is a lazy method, but it's very, very powerful. All right, so we have talked about the chicken and the rabbits question. Now, let's take a break and let's look at other questions. Let's see, let's input another question. The next question we're going to talk about is the problem number 2. So it'll be same as problem number 1, but the total number of heads is 100. The number of legs is 350. Question again, the same. How many rabbits? So again, take a pause, look at, try to apply the methods you have learned in problem 1. Does not matter which method you do, just try your method. Take 2 minutes, 3 minutes, try to solve it. And here I'm going to just focus on the second method, the unit operation method. And let's just practice to see if we really understand this. Okay? So we're going to use the method of unit operation. We're going to assume all animals are chicken. Which means 100 are chicken. So the total number of legs equals, if everything is chicken, will be 100 times 2 equals 200 legs. But the problem says the total number of legs is 350. What's the difference? So from 200 all the way to 350, we need to increase by 150, which of course is 350 minus 200. How we are going to increase? And of course we know is by replacing chickens by rabbits. But we know replacing one chicken by one rabbit, what's the increase? Is minus 2 plus 4. Taking out the 2 legs plus 4 legs equals a 2. So every replace increase the number of legs by 2. So how many replacement we need to do to get 150? Easy. 150 divided by 2 equals 75 replacements we need to do. Which means 75 rabbits. Okay, do you like this approach? No algebraic equations, no equations. Okay, just intuition and simple counting, simple divide. That's problem number 2. Let's look at another problem. Problem number, let's see, actually, let's do problem number 5. This problem will be slightly different. There are 50 girls and 50 girls and boys. Okay, total number of kids are 50 in a class who are planting trees. Each girl plants 4 trees. Each boy plants 2 trees. If the total number of trees planted by girls are 20 more than that by boys, how many boys are in the class? Let's make it slightly smaller. Okay. So again, take some time to think about it. I would recommend you using the unit operation method, and that's the method I'm going to focus on. And for this problem, I'm also going to use the algebraic method as well to describe it. So let's do the first method. I assume you are taking your time already. If you have not done so, please pause and try to solve yourself first. Okay, I will do the unit operation method first. Let's assume all 50 are girls. So then the total number of trees planted by girls will be equal to 100. Of course, that's 4 times 50. Total number of trees by boys will be equal 0 times 2 equals 0. Okay, so the difference will be the difference, because the problem says the total number of trees planted by girls are 20 more than the boys. Now the difference of the trees, number of trees by girls minus the number of trees by boys is equal to 200 minus 0, equal to 200. That's way more than the 20. And the fact, of course, is because that there are boys there who planted trees. So let's look at the unit change. If we replace that's some technical errors on the pen. So let's restart on this. Okay. That's using the unit operation method. So we started that if all are girls, let's see. That's number of trees, the total number of trees by girls. Minus the number of trees by boys. Equals 4 times 50 minus 0 equals 200. And every time, if we replace one girl by one boy, what is the change in terms of the number, this quantity, the number of trees by the number of, by girls and the number of trees by boys? So you are going to take out 4. The change on that quantity, on this, is going to, you take out 4 and take out 4, but you're not adding 2, you're also minus 2 because the total number of trees by boys is subtracted there. So every time you are reducing by 6 this amount. Okay, this probably takes a minute to think about it. You see, I'm taking the difference between the number of trees by girls and number of trees by boys. Every time I'm taking out one girl, I'm reducing this amount, and I'm increasing this amount. Reducing by 4 here, increase this by 2. So the total number, the difference, it will be minus 2 minus 2. Minus 4 minus 2 equals minus 6. A change is reducing by 6. Okay? And this is true for every time when I take a girl replaced by a boy. Replacing one girl by one boy. It's going to be reducing the number of trees difference by 6. And what's the target? We need to, from 200, reduce to 20, which means a reduction of 200 minus 20 equals 180. And every replacement is going to be 6. So number replacement will equal 180 divided by 6 equals 30. What does that mean, 30? That'll be 30 replacement, will be 30 boys and 20 girls. Of course, that you are going to take this answer and verify. Let's see, 30 boys, 20 girls. 20 girls will be 80. 30 boys plant 2 trees each will be 60, and the difference will be 20, and this is correct answer. Okay, so this will be the end of this lecture, and we have 3 problems that we did not cover, and you should look at what we have learned in this lesson and try to apply the techniques there. And to recapture, we learned 3 methods. First is trial and error. Trial and error is a so-called brute force method, and there's nothing wrong with trial and error. It's actually a very good way of understanding a problem. And the second method is the unit operation method, which is our focus in this lecture. And the third method is algebraic method, and you're going to use it as you grow more sophisticated on those approaches. But at this stage, especially for younger kids, I don't recommend it. I recommend this unit operation method. Okay.